Good morning, students. Now let's begin with the second topic of this chapter, and this topic is solubility. Now, solubility means the maximum amount of a substance which can be dissolved in a specific amount of solvent. The first subtopic in this section is solubility of solids in liquids. You know, solids easily dissolve in liquids. Now, how to define it? It can be defined as the amount of the solid that dissolves in 100 gram of the solvent at a given temperature to form a saturated solution. Now, what is the meaning of saturated solution? Saturated solution means no more solute can be dissolved further. Now, solubility of solids in liquids depends upon the following factors. The first factor is nature of solute and solvent. So what is the nature of solute? What is the nature of solvent? Now, how this affect the solubility? We know this thing that every solid does not dissolve in a given liquid. Now, for example, your common salt NaCl, it readily dissolves in water, but it does not dissolve in oil. Now, how to explain this? So this is in accordance with a basic rule that we have learned in 11th class also. Like dissolves like. Polar substances which are ionic in nature dissolve in polar solvents like water, whereas non-polar substances which are covalent in nature are soluble in non-polar solvents like benzene and ether. So your sodium chloride is an ionic compound, it is a polar substance, and your oil is a non-polar substance. So sodium chloride does not dissolve in oil. The second factor which affects the solubility is the temperature. Generally, we have one thing in our mind that solubility of a substance will increase with rise in temperature, but this is not the fact. The solubility may increase or decrease with rise in temperature. For most of the substances like sodium chloride, NH4Cl, ammonium chloride, sodium nitrate, the solubility increases with rise in temperature. Now listen carefully. What is the reason behind this thing? This is because the dissolution process for these substances is endothermic. Now, what is the meaning of endothermic? Endothermic means when such substances are dissolved in water, heat is absorbed. If heat is absorbed during a process, we know what is the sign of enthalpy change, delta H, it is always positive. Now, we have learnt one basic principle in 11th class, that was Lee-Chatelier's principle. So this all is in accordance with Lee-Chatelier principle only. Whenever the process is endothermic, you remember this thing for always. Whenever the process is endothermic, it is always favored by rise in temperature. So if you increase the temperature, the solubility of these substances will also increase. But on the other hand, there are some substances like lithium sulfate, cerium sulfate, which have solubility that decreases with rise in temperature. Now you can relate the two things together. What is the reason behind this? Because whenever such substances are dissolved in water, the dissolution process is exothermic, that is delta H, enthalpy change is negative. So according to Lee-Chatelier principle, an exothermic reaction is always favored by low temperature condition. Okay, now the second is solubility of gases and liquids. Gases also dissolve in liquids to form homogeneous mixtures or solution. The solubility of gases and liquids depend upon. The first factor is again, what is the nature of gas and what is the nature of solvent. The different gases are soluble in water to different extent. You know, gases like your nitrogen, oxygen, hydrogen, they dissolve in water to a very small extent. Whereas there are gases like ammonia, sulfur dioxide, which are highly soluble in water. Now, what is the reason behind this? This is because these gases, NH3SO2, these chemically react with water to form compounds like NH4OH, H2SO3, it is a sulfurous acid, etc. It means only those gases are highly soluble in water which chemically react with water. Your oxygen and nitrogen, they do not react with water at all, so they are less soluble in water. On the other hand, these oxygen, nitrogen, they are much more soluble in ethanol than in water. Now the second factor which affects the solubility is the effect of temperature. The solubility of a gas decreases with rise in temperature. Now we can relate the things. The solubility is decreasing with rise in temperature. It means definitely the process is exothermic process according to Lee-Chatelier principle. So this is again in accordance with Lee-Chatelier's principle, since the dissolution of gases is an exothermic process. Also we can say like when we increase the temperature, the kinetic energy of gas molecules also increase rapidly. So they escape out of the solution. Okay. Now the third factor is effect of pressure, and this factor is important factor. The solubility of gases increases with increase of pressure. The quantitative relation between solubility of gas in a solvent and pressure is given by Henry's law. So Henry gave a mathematical relation between the solubility of gas and pressure. Now what was Henry's law? Henry stated that the mass of a gas dissolved per unit volume of the solvent at a constant temperature or given temperature is directly proportional to the pressure of gas in equilibrium with the solution. That is, M is proportional to P. So more is the pressure of gas above the solution, and more will be the mass of gas dissolved in the solvent. Now, if we use mole fraction of the gas in the solution as a measure of its solubility, which is more appropriate as compared to the mass of a gas, then Henry's law can be written as X is proportional to P. Now, what is X? X is the mole fraction of gas in the solution. In the solution, because gas is present in the solution also, and gas is present above the solution also. And P is the partial pressure of gas over the solution. Now, if you remove the proportionality sign, it will be X equal to K dash into P, that is a constant. So P is equal to 1 upon K dash into X. Now 1 upon K dash is replaced by another constant KH, which is known as Henry's law constant. So what can be the alternate statement for Henry's law? Now, if suppose the question comes in the board examination state Henry's law, then you will write this statement. The partial pressure of the gas in the vapor phase. In the vapor phase means the pressure of gas above the solution is directly proportional to the mole fraction of gas in the solution. Now, Henry's law constant. So the value of Henry law constant depends on nature of gas. Different gases have different values of this KH. Now, one important thing, higher is the value of KH at a particular pressure, the lower is the solubility of gas in the liquids. So for those gases which have higher value of KH, the solubility of those gases will be less. As temperature increases, the KH value also increases. So now we can relate. So as your temperature will increase, your KH value will increase. So the solubility of gas will decrease with rise in temperature. Now there is one important question which is given in NCERT book also, and this question was there in last year board paper, that why aquatic species are more comfortable in cold water than in warm water. So in warm water the temperature is more, and when the temperature rises the solubility of gas decreases. So you know, in water aquatic organisms use dissolved oxygen for their survival. So as the temperature will increase, whatever oxygen gas is dissolved in water, that oxygen will escape out. So aquatic species are more comfortable in cold water. Now we come to the next topic that is applications of Henry's law. Now the first application, in the production of soft drinks. You know, your soft drinks and soda water contains dissolved carbon dioxide in it, and to increase the solubility, what they do, they increase the pressure of carbon dioxide. That's why the bottles are sealed under high pressure, and as soon as you open the bottle, the gas comes out rapidly, because inside the bottle the pressure of carbon dioxide is more and outside atmospheric pressure is less. So as soon as the bottle is opened, the gas escapes out in the form of bubbles. Now the second application is at higher altitudes. Now what happens? As we move up, the atmospheric pressure decreases. So at higher altitudes, the partial pressure of oxygen is less than the ground level. This we all know. So what will happen? It will result in low concentration of oxygen in the blood of mountain climbers as well as the people living at higher altitudes, because we know one thing that smaller is the pressure, less will be the quantity of gas dissolved. As a result, the mountain climbers become weak and unable to think clearly, because if the concentration of oxygen is less in the blood, less oxygen will go to brain and other important organs, and this condition is known as anoxia. The third application in deep sea diving, that is known as scuba diving. Now what the deep sea divers do, they take compressed air. Compressed air means the pressure is more, containing nitrogen and oxygen for breathing at high pressure under water. So at great depth, what will happen as the diver moves down? Now what will happen? The pressure of water increases. So more and more nitrogen dissolves in the blood, and whatever oxygen is dissolved in the blood because of the high pressure of water, that oxygen is consumed in the metabolic activities. At great depth, more nitrogen dissolves in the blood because the pressure of water is more. Now, what will happen? When the diver comes towards the surface, now the pressure of water will decrease. Oxygen was already consumed in the metabolic activities, but the nitrogen, it comes out of the body quickly in the form of bubbles. Now these bubbles, what they do, they will restrict the blood flow, they will block the capillaries, and this is a very painful condition which is known as the bends. So when the diver comes to the surface, he feels quite pain because of the blockage of this blood capillary, and to avoid this problem, nowadays what they do, the divers use air which is diluted with helium. Now two reasons are there behind this. First reason is helium is less soluble in blood as compared to nitrogen. And the second reason is because of the small size of helium atoms, unlike nitrogen, they can easily pass through the cell walls of blood vessels without damaging them. Good morning, students. Now the concept of Henry's law must be clear to you, and the applications also. Now we'll be solving a numerical which is based on Henry's law. The question is, if nitrogen gas is bubbled through water at 293 Kelvin, how many millimoles of nitrogen gas would dissolve in 1 liter of water? Assume that nitrogen exerts a partial pressure of 0.987 bar. KH, that is Henry's law constant for nitrogen, is 76.48 kilobars. Now how to solve this question? So first of all, we'll apply the formula. P is equal to KH into X. Now what is P here? Partial pressure of nitrogen. What is KH here? Henry's law constant. What is X here? Mole fraction of nitrogen. So mole fraction of nitrogen is equal to partial pressure of nitrogen upon KH. It is equal to 0.987 bar divided by 76.48. Now I have multiplied this by 1000 because the value is given in kilobars. So it will change into bars. The answer would be 1.29 into 10 to the power minus 5. Now mole fraction of nitrogen is equal to number of moles of nitrogen divided by number of moles of nitrogen plus number of moles of water. Now listen carefully. The mole fraction of nitrogen is having very low value. It means that as compared to the number of moles of water, the number of moles of nitrogen are very, very less. So in the denominator part, we can neglect this thing, number of moles of nitrogen. So this formula can be simplified as number of moles of nitrogen upon number of moles of water. How to find out moles of water? In the question it is given 1 liter of water. Since the density of water is 1, so 1 liter of water is approximately equal to 1 kilogram of water. 1 kilogram means 1000 gram. So how will you calculate number of moles of water? Given mass will be 1000 gram for water. Molar mass of water is 18. So this value will come around 55.5 moles. Now mole fraction of nitrogen is 1.29 into 10 to the power minus 5. Number of moles of nitrogen we have to calculate. What is the number of moles of water? It is 55.5. Now if you solve this thing, number of moles of nitrogen will be 7.16 into 10 to the power minus 4 moles. Now in the question millimoles are asked. So how to change into millimoles? Multiply this by 10 to the power. Now millimoles we have to change. So we will multiply this by 10 to the power 3. So it will change 7.16 into 10 to the power minus 1 millimoles. This is the answer.